Thank you very much. Hey everyone, I'm Steve Guerrero with Pendulum. I'm the CTO of Pendulum. I've been with the company for about 4 years now. The company actually has its genesis back in 2013, doing AI before AI was cool. And we are applying AI to AT&T and GPS-denied geolocation. The genesis of this work is it came out of a phase 2 CIBR, a direct-to-phase 2 with Ralph Kohler at AFRL, and was inspired by the baroNav work at AFIT, using the barometric altimeter that's in a smartphone to improve AT&T and give you a feedback signal so that your error from your dead reckoning sources when there's no RF or GPS available from continuing to diverge over time. So rather than having your error be some drift that is like 100 meters per kilometer or something like that, and it's just monotonically increasing and increasing, we're able to look at the terrain around you and use that as a feedback signal to really refine your position and keep that error from accumulating. I'll go into more detail of how all that works, but there's been a number of CIBR efforts that have been awarded to improve this technology. So there was the initial phase 2 CIBR, and then we did a CIBR working across a network of devices. So if you have 5, 10 devices on your TAK network and they're all talking to each other and they're all collecting data, how do you share that data to improve everyone's position? We've applied this to drones and wearables. And now we've done a TAKFi to transition this from a TRL6 gee whiz prototype to something that's TRL8 and ready to be transitioned. So the product architecture is we're using just the internal sensors on the phone. There's no external kit, no external hardware, and you don't need GPS. And all of the compute is done right on the phone. There's no backhaul to the cloud. So we bring in the sensor data, so that's the accelerometer, the gyro, the magnetometer, the barometric altimeter, and then fuse that with digital terrain data. So if you have really good 1 meter LiDAR data, that's available on NGA Grid for most of the world right now, so you can download that onto your device before your mission, you're ready to go. Or we could fall back on using DTED level 2 data, so if you have 30 meter post data, that's good enough, but the 1 meter LiDAR data works a lot better. So we fuse all that sensor data with land cover and digital elevation data to update your position in real time. So as you move through your environment, we're able to track you. Right now we're focusing on the dismounted use case, so dismounted soldiers walking around in an environment. We don't assume that they're walking on roads. It's all free range, just looking at the elevation. We're able to store that data locally or communicate it back up to the cloud if you want to look at things later, but you don't need to do that. You can own all of your data. You don't need to send it back to us. So this is a video of this working in the hills of Virginia. We were out by Shenandoah and set up a land nav course and started it, the night before we put all the waypoints in, put it into ATAK. And then the next day, we walked around and followed that land nav course. No GPS, just walking through the fields. And this is how it was performing. In general, we're within 50 meters of ground truth throughout that entire course. Some of the error bars are larger, and we've seen errors, out to 100 meters or so, but then it's able to correct when it sees a signal from the elevation. We also, do a lot of improvements to the ATAK interface. So one of the things you see is that we give you a heading cone, so that way you know where you're facing, and you can quickly see if if your heading error is very wide, and you can do wave your phone in the air and recalibrate it. We also add this manual position update reticle on the left-hand side there, so you can quickly drag that to update your position, and that'll reset the model to that new position and keep moving. Right now, the phone needs to be chest mounted. We're working on bringing that so you could throw it in your pocket or a backpack and have it work wherever you have your phone. But for now, it does need to be chest mounted. We've been trying to measure the power draw of the device, and it's really negligible in the noise compared to what ATAK is doing. So if you're running ATAK, you won't see a significant power difference by using our software. We've also been a big test bed for what AFRL has been doing with some of the other advanced ML projects that you've heard about this week. So we were, I think, the first APNT NavAid to integrate with Northstar, and now the location provider framework that's in core ATAK for giving our location updates right to ATAK. So, you know, we're taking over the self marker and using that. It's not like we're cluttering your screen. Like and you can turn off that heat map, so it really does, you could make it look just like any other position that you're getting from GPS. We were also, I think, the first company outside of BBN to integrate with their ATAK-Mil framework for doing machine learning models on device. We've tested this across a bunch of different environments where they're doing active jamming. So we've gone to Pentax a couple times. We went to NavFest. We did some work up in Fort Drum. And we've done a couple of the SOCOM TE events. So we were out at Arctic Warrior 25-1 and sort of testing it in Arctic conditions with our NATO allies as well as special forces. So our software is resilient to jamming, spoofing, and indirect interference. We're not using any signals. Right now, we're not detecting jamming, but that's on our roadmap. And if you suspect there will be jamming, it's really easy to turn the navigate on and reject jamming. Our error rate is non-compounding. We have low swap-C. We're fully integrated with ATAK. We're not ITAR restricted, so our partner allies we can work with. And we've worked with units and had the software deployed and had them trained and ready to go after 2 one-hour meetings with them, walking them through how to use it and how to set it up and how to load data and everything. And we've had them evaluate it and, give them the software, let them walk around with it however they'll use it, not a controlled environment. And they've seen the same error rates that I'm telling you here. So I'm going to switch over and give you a bit of a live demo. So here's my phone here, and I don't have GPS because we're in this building. So to start Navigate, you click the Navigate icon. I've loaded the plugin and have elevation data and everything for here. If you know your pace count, you can go ahead and finger it in. So I'm about 67 steps per 100 meters. Put that in. And then we need to know information about you to understand how you move in that environment. So what we've found is your height, weight, and seam and gear weight are the important factors that affect how you move in the environment. Right now it's set up for metric, but it does localization, so if you're stateside, it should automatically say that you should use English units, but if not, you can change that. So I could say, carrying 2 pounds, and then you're ready to go. So you hit Start Navigate, and you get a toast notification saying that Navigate has started. You see our error ellipse and our heading. If you click on the Navigate On widget, you get some health information about the sensors and your heading. You can see that my heading right now is quite bad because I'm plugged into my phone, and the current from the charging is actually affecting the magnetometer. So if I do that, you'll see my heading is still bad because of the cable that I'm plugged into, but it's usable. And we use that heading error to improve our models because we know that we can't trust your heading. So then if I were to walk around, I can't because I'm plugged in. this would move and track me as I walked around. You do need elevation data, so we're not currently working inside buildings. You do need to be outside where there's decent elevation, or where there is elevation data available. But we are working on bringing this towards indoor navigation. So right now we're actively looking for transition partners to bring this from an S&T project to be fielded. Yeah, if you're interested in transitioning with us, I'd love to talk to you. I'm going to pause there and take some questions. Can you go to the microphone, please?
So while walking outdoors on a flat ground, more or less flat, can you still take advantage of that? And if the user also does a squatting and getting up, do you track those kind of small elevation changes?
So the question was about walking on flat ground and also tactical movements. So in a flat ground, your error does increase, but even small elevation changes are enough for us to get a feedback signal from it. So, you know, if it were a football field, you would see that your error rate would be relatively large. But, you know, we're still talking within 50 meters or so. We change our models based on the terrain you're operating in. So if you're in a flat area where there isn't a large elevation signal, we weight your heading more and weight some other parameters more and use different models for that type of terrain to improve your performance in that terrain. Where there is, when you do have significant elevation, we're able to use models that more heavily weight that type of terrain and improve that performance. As for tactical movements, we've found that, you know, we've worked with groups who have used this during exercises, and we haven't, we've included some of that in our training data, so we have a huge corpus of training data that we've collected for doing our machine learning models. So we're able to include those movements in the sensor data that's coming in, and the machine learning takes care of that. Sure.
In this case, imagine you're on the street level, but there's the building, so there's basically elevation, abrupt changes in elevation with very small, so like boundary effects. And you said you use the LiDAR. If you use the LiDAR, 1 meter LiDAR is good, but that would have the building, the top of the building, the height.
So it depends on what kind of LiDAR data you have. There are two different kinds of elevation models. You can have digital surface models and digital terrain models. Yeah. So things like in digital surface models, it tracks the top of the foliage, it'll track the top of the buildings, it'll include all of that information. Digital terrain models give you the bare earth elevation and flatten where buildings are, so you don't get those abrupt changes in elevation. We use digital terrain models.
So you may have said it and I may have missed it, but I'm not sure. How did you initialize your position here? Did you manually initialize it?
Yeah, so if you have a good position from GPS to start with, we can use that. You can manually position it either using the ATAK lower right hand corner thing, or you can use our update position widget. We could also take a position from other nav aids that are out there. So for example, Skyline is going to talk today and they have something where you can take a picture of a skyline and it'll tell you where you are. So you could use that to initialize your position. And our initial position doesn't have to be perfect. So if you're in the ballpark, we'll correct to where you are. If anyone wants to try it out after this, I'll be around and I'll have some chest mounts and we can go walk around outside and you can see how it works for yourself.
Maybe you want to do a walking tour of New York City or Washington, D.C., Arlington, I guess, with a group of people all at once so you can discuss it as you go.
Mm-hmm.
Just a thought?
Yeah. All right, I think we'll pause there. Thank you very much.